Hi everyone, I'm Alex, here being the moderator of the NTN IoT community for this webinar. We're just waiting for a few, let's say 30 seconds for more people to join, and then we start. Okay, I think it's a good moment to start. So today with me, we have Shahbaz Ali, Head of Product of Sateliot, and Ajit, Senior Solutions Engineer of AWS, and they will be discussing about the topic of 5G over non-terrestrial networks and how can it be, integrated, accelerated through the use of a hyperscaler like AWS. So I think the first part comes from Shahbaz, so feel free to start.
Alex, for arranging this webinar. Thank you, Ajit, for joining in. Thank you, NTN IoT community. Okay, so today, as the topic says, we will talk about the 5G and the uses of 5G IoT in accelerating the IoT connectivity. So first, let's see what are the basic use cases where 5G can be implemented. So we talk about enhancing the mobile broadband. Here we are talking about certain parameters, like we are talking about peak data rates for 20 gigabits per second in the downlink and 10 gigabits per second for the uplink. Or you can expect from the user experience data rate 100 Mbps downlink and 50 for the uplink. We are also considering the parameters for the spectral efficiency. In mobile broadband cases, we can experience the low cost per bit, and most of all, the energy efficiency is very vital in this case. Nutshell, we are talking about gigabytes in seconds for this use case. Then it comes to the ultra reliable and low latency communication. When we talk about 5G, we are talking about self-driving cars, augmented reality, mission critical applications. For all those applications, some parameters are very important, like we are expecting low user plane latency, let's say 1 millisecond. We are talking about low control plane latency, it's 12 milliseconds. We need to have the reliability for such use cases, and with 5G we can have like 99.999% success rate. That's why it is helping the overall use cases to deliver. And then we are talking about mobility interruption time, 0 milliseconds. Then at the last comes the most interesting, I would say, the use case is the IoT NTN, or machine-to-machine communication, where we can have the connection density up to 1 million devices per square kilometer. Though it's sometimes it's really challenging to attain. It depends on certain parameters, but it's possible. We can say through 5G technology, it's possible. With such devices, we need longer battery life, and thanks to the 5G protocol, we can expect the battery lives up to 10 years, 15 years. And for different applications, we can also expect low data bandwidths from 1 kilobits per second to 100 kilobits per second. And this means we are talking about enhanced coverage. That's the power of the 5G. If you can go to the next slide, please. So if we see the overall 5G spectrum in a quick view, we can say the higher the frequency, the faster is the decay. So this frequency attenuation, the interfaces are much more if you have higher frequencies. And if you have lower frequencies, that means that you can get more user per cell. The density of the connections is much more dense with the lower frequencies. And if we look the overall spectrum, Alex, can you move to the next slide, please? So we can divide the overall 5G spectrum into three categories, you can say. On the right side, you can say high throughputs, where you have higher bandwidths, high throughputs, which are supposed to use for the mission critical use cases, as we spoke earlier. And then from the capacity, when you need the capacity, we had the mid band. And then when we need to provide the coverage, the more density, more densely covering the devices and the connections, and then we are talking about the lower bands of the frequency. So we can say the frequency range 1 is starting from 410 megahertz to goes up to 7125, and then frequency range 2 like 24.2 gigahertz to 52 gigahertz, you can say. So this is the, like in a nutshell, the segregation of the 5G spectrum in terms of the capacity and coverage and throughput. So if we now talk about what is the 5G over NTN, 5G over non-terrestrial network. Non-terrestrial network is the next big thing, I would say, after the revolution of the IoT. The next thing is the IoT over NTN. So 5G protocol over an NTN is used to deliver the wireless connectivity for the remote locations using the satellite. So from the space side, we can say that the segregation can be done into two major groups, is the NGSO and the GSO. And GSO, we are talking about the non-geostationary satellite orbits. We have LEO, MEO, and HAPS in this category. We can say that these are mostly covering the delay tolerant applications. They have the better link budget to support the much more lower distances, due to the much more lower distances. If we talk about the GSO, geostationary satellite orbits, so we are talking about critical services, broadband connectivity, where we require the continuous coverage. For example, mission critical and the broadband, other use cases can be served efficiently with the GSO satellites. So let's talk about like the key features and the advantages of the 5G NTN. So we can say the division in three major categories in terms of the use cases. We can say from IoT, D2D, direct to device, and the broadband. So if we talk about the IoT, the key features for 5G NTN, you can have the improved coverage versus the terrestrial network. Terrestrial network, of course, has some limitations. That's why what we are referring to is the improved coverage, the enhanced coverage of the network. Then we are talking about the low latency, talking about the NGSO, lower altitude satellites, HAPS. So that's how we are supporting the low latency in IoT use cases. We are also talking about scalable with respect to the data demands. The data rates are scalable as per the demand emerges. And also the most important factor for IoT use case is the energy efficiency, the power consumption. We are talking, let's say, we can talk about the implementation of narrowband IoT over 5G. So that's the implementation where you can have the energy efficient devices in different use cases. We're going to talk about in next slide what are the specific use cases. But these are the parameters that allows the implementation of 5G over NTN. And then we can say the harmonious network switching between the terrestrial and the non-terrestrial network, thanks to the standards like 3GPP release 17, that is allowing the extension of the standard to the NTN, and the harmonious network switching is possible implementing those technologies. Now, if we talk about the direct to device on your smartphones, there you must have seen different announcements from different companies in this area. So there we have the direct to device implementations available. Companies are working on it. And again, some of the feature sets, some of the advantages are pretty similar as per the standard. We can have the improved coverage versus terrestrial network. Again, it's low latency if you use the NGSO. the higher throughputs. For the direct to devices, we can have the higher throughputs from 5G. Spectrum efficiency we can achieve for the direct to device use cases. And again, with the power of the standard, we can have the network switching, harmonious network switching, seamless network switching between the terrestrial network and the non-terrestrial network by implementing the standards. Lastly is the broadband, is the different use case, but of course it can be served. Some of the key features are the same. What you can see is the enhanced broadband implementation, and the use case can be well served through the 5G NTN technology. Lastly, if you can see the key use cases in each area, we can talk about in IoT, we can talk about agriculture, energy and utilities, mining, oil and gas, environmental, transport and cargo, renewable energies. All those use cases can be well served by 5G NTN. If you see the broader horizon, the use cases require the low latency, the delay tolerancy, and the low power consumption devices. That's why the power of the technology, it allowing the all those devices and all those implementation to extend and serve their respective customers in much more lower cost that we are talking about. So this is all possible through the extension of the 5G NTN. If we talk about the direct to device, the smartphones, we can say it's the content sharing, the files and videos, public safety. You must have seen some announcement from leading mobile manufacturers companies for showcasing an SOS feature. So these are some technologies which are extending direct to the device, and they can be efficiently serve the right customer base. Also, we are talking about connected vehicles. On the broadband side, you can say we are talking about high definition video surveillance use cases, gaming and esports, remote education, smart manufacturing, telemedicine, entertainment and events, remote work. So these kind are the use cases which can be efficiently served through extension of the 5G NTN wherever it becomes relevant. So now I hand over the floor to Ajit for talking about the role of hyperscalers in 5G NTN.
Perfect. Thank you very much, Shehbaz, and thank you very much for sharing the need of running 5G over non-terrestrial networks. I'm going to be talking to you about what it takes to build 5G and what it takes to kind of enable 5G over your non-terrestrial network. So let us take a look at first the characteristics of what 5G over non-terrestrial workloads entail. Like, what are the characteristics of these workloads? Firstly, you need to have a radio access network that traverses your satellite constellation, or in maybe it can also be balloons if you want to send in stratosphere and run your network across, which is also non-terrestrial in a way. But you need a radio access network which needs to traverse the non-terrestrial piece of it, right? So you need to adapt your radio standards to kind of work with your sorry, Alex, can you go back to that slide? Yeah. You need to kind of make your radio work with 5G standards. Secondly, you need to have a packet core that can support integration and support the 3GPP standards for 5G. And finally, you need to have an operational and business support system that can manage your functions across your communication path. So now that we have established the characteristics of 5G workloads for non-terrestrial networks, let us see what are the challenges we face in building this. So next slide, please, Alex. So what are the challenges that customers are facing when they want to enable 5G over their NTN network or over their satellite constellation, right? So first is they need to build a dedicated cloud. What do I mean by a dedicated telco cloud? 5G by design is virtual, all the functions, like if you look at the 5G specification, it is built with distribution in distributed architecture in mind, right? So you have the control unit, or sorry, you have the central unit and you have the distributed unit where your user plane functions reside, or user data functions reside, while in the central unit you have your authentication functions, network slicing functions, right? So the architecture itself is microservices. So essentially you need to kind of have a span of technology, or a platform where your central units and distributed units can be spread across, and they can support the various traffic flows and various network slices that you build over your infrastructure. Secondly, as these different functions are say distributed, you need to kind of run them either in a central region where you may have a lot of capacity, but to reduce the latency you may also need you also need to run these functions at edge, so that you can cater to those low latency workloads and high reliability workloads at the edge. And as you can imagine, as as these functions are increasing, as the amount of pieces that you have in your architecture increases, it is very critical to kind of have an orchestration and automation layer. You cannot have a different orchestration for running your core, and a different orchestration, or the central units, and a different orchestration for running your user data units. So it's essential that you kind of build an orchestration and automation piece which can manage your end-to-end 5G architecture, and that is another challenge that customers face while building 5G cloud for non-terrestrial networks. Secondly, operations for day two operations for managing these workloads can be extremely complex, and it is important to keep assurance like service assurance for customers, so they don't see so you don't see a churn and people leaving your network because there is no assurance on your network. And overall, there is no way you can remain in the market if you cannot monetize the service or the cool service that you have built. So essentially, faster go to market with more and more services. And as Shabazz mentioned, the release 17 of 3GPP is just a beginning of 5G over non-terrestrial, as future releases will enable 5G standards for broader use cases beyond IoT, even to broadband and device to device. There will be a need for releasing services faster to market and be more agile, so you can capitalize on that investment that you have done. So now that we have seen the customer challenges, let's take a look at how AWS can help you overcome these challenges and build the network of future for IoT. Next slide, please, Alex. So some of you may have come across this slide in some AWS event. Essentially, it kind of gives you a 40,000 view of what AWS services and where they span. So we started back in 2008, and our services were mostly located within regions with massive data centers, massive compute and storage, and database capacities, right? And customers were building their workloads in region. Even today, we advocate that any workload that can run in region should be run in region. However, as we see with 5G standards, things and with ever increasing amount of devices that can do compute at edge, there is an increasing demand of providing compute at edge locations. And with 5G, we spoke about the user data plane functions. These need to be run at edge, so you can have a low latency exit from your device to the internet, or to the private network wherever you intend to go. And that's where AWS started investing in edge services, where we have outposts which extend your region with AWS hardware inside your own data center and extend services from AWS region to your own data center. So you can really have a seamless user experience deploying whether in region or inside your own data center. There are AWS local zones, which are essentially in metro centers, which allow you to kind of have AWS services in a managed manner without you having to manage or install any racks or outpost racks. And finally, we have AWS wavelengths as well, which essentially are a smaller footprint of AWS services, which are generally closer to existing 5G terrestrial edge locations, which provide you with even more choices of where you can run your edge computing workloads. Finally, if you look at the extreme right spectrum, we have the rugged and mobile edge devices with the AWS Snowball family. Or if you look at the AWS Snow family, these are edge devices which don't even need a continuous connectivity to AWS, and these can be and then these are designed to run in a very harsh environment. So say for example you want your 5G to kind of support maritime applications or mining applications, and you don't really have a way to have continuous connectivity in those locations, and the environments are quite rugged. So you can really take a look at, or you can really leverage the AWS Snow family to run your compute at these edge locations and still have the power of AWS experience, and use the same tools and same mechanisms to deploy at these remote locations as well. Next slide, please, Alex. So now that we have established like how AWS services span from region to edge all the way to the remote edge, right? I want to kind of zoom in and demonstrate or talk about how these different environment and how this different infrastructure that AWS provides fits into the 5G piece, right? So what are the different functions that you may run on in region or at an AWS edge location and so on. So starting from the very left, you can see the AWS region, which has all the capacity that you may need to run a highly scalable 5G core. You can run that in region. So essentially your 5G core or 5G core control plane, your BSS and OSS systems, they can run in AWS region, while you can have your user plane functions, user data functions completely offloaded to outposts or local zone, where you can orchestrate the network slices, you can provision the network paths the way you want from the core, while when the user data traffic comes in, the policies are applied at a location nearest to them, and then they are exiting out to the intended destination. And ideally, if you look at how this will pan out in a non-terrestrial world, is like in a terrestrial network, you would have these outposts closer to your terrestrial RANs. But in a non-terrestrial network, these would be located in your ground segment infrastructure. So you can have these compute instances or these compute nodes as close as possible to the downlink capacity as you can, and then have that exit directly out from that ground segment infrastructure. Next slide, please, Alex. So now that we have established like how AWS services can help you build your 5G services for non-terrestrial networks, I want to kind of focus on a couple of things on why you would want to use AWS hyperscaler like AWS to build your 5G code. So let's first focus on why OSS and why BSS systems on AWS. So let me put it this way. Forget about the slide. Forget about the bullet points that I'm showing here. As you are building these school services, as you are building this network for the future to support a massive communication across remote locations, you need to monetize them. You need to build these services. Without having a way to build these services, you will not be able to remain in the market for long, right? And at the core of building any business is making sure you can monetize it. And if you look at the OSS and BSS systems of the past, like as the 5G architecture has evolved, your OSS and BSS systems need to support this complex architecture as well. So you really cannot have these single hardware boxes with 4 lights on, red, blue, green, and do the OSS BSS in just a single a device that is sitting in your core location, in your central location, right? Even your OSS and BSS systems need to have the tentacles spread across the user plane functions across the central, and it needs to be scalable. As your business, as your 5G connections will scale, your OSS BSS needs to scale as well. So that is the reason why you will have to kind of rethink about the way you do your business operations, your billing operations, and your service assurance operations in 5G era. And now if you look at the key points here, it gives you an automation across the network and a faster time to market if you deploy on AWS. So you're getting the same tools that you will be using to deploy your other functions, like as you deploy your Kubernetes, or as you deploy your, not Kubernetes, but as you deploy your regular applications, maybe using a Kubernetes cluster, you can use the same infrastructure to deploy your OSS and BSS systems. And it allows you to focus on implementing new business models, focusing on business rather than focusing on how do I manage a new kind of machine or new kind of a box in my environment, right? You can use the same resilience and reliability that you are already building for core boxes, and you are able to leverage the same expertise of AWS platform to kind of build your BSS and OSS systems. And finally, you get to have a lower cost of entry into these markets. So as you see, 5G NTN is quite new, and telco space is already established, right? So every customer who is entering into this space, they already have to kind of uh, catch up to the innovation and catch up to the pace of the telcos. And having this infrastructure already available to you for running you and building your BSS systems and operational systems, it allows you to lower the entry barrier into into this segment. Next slide, please, Alex. And finally, I want to talk about, so we discussed about why we want to build the billing systems and operational systems on AWS. The same principles apply to why you would want to build 5G core on AWS. We spoke about how 5G adoption is only going to keep increasing with this new or with the release 17 supporting non-terrestrial networks, right? In a recent study, it was shown that there are around 1.9 billion 5G connections today, and this is expected to increase to up to 6 billion connections by 2027. So if you are building a 5G service today, you need to keep in mind the scale it will achieve in next 2 to 3 years. It is going to be exponential. So 2 billion to 7 billion, it's an exponential increase. It's not just 3 times, but it's the amount of scaling you need to do on your infrastructure is actually exponential. So to be able to support this kind of scale, you will need to have the infrastructure that can scale based on your demand. And you don't want to put your capital in kind of building a model which is not even giving you revenue right away. So it allows you to lower your total cost of ownership, because you can start small and then you can grow as with cloud services, with AWS services, as your demand grows. We already spoke about automation and productivity as it applies to BSS, OSS, or any other service layer functions that you are building. And the same will apply to your core functions running on AWS. You get the operational resilience. Your core is the heart of your 5G network. If the core is not resilient, your 5G network is not going to support the SLAs that you have committed to your clients. So AWS infrastructure allows you to build a service which is operationally resilient, which is redundant, and allows you to build services which can cater to the SLAs that you have committed to your clients. And finally, business agility. You leave the complexity of managing the infrastructure to to hyperscalers like AWS, while you focus on building new services and new revenue streams for your business. So you are reducing that time to market. This is real agility in terms, right? So agility is not like deploying a container in two business days, or deploying a code in 2 business days. It's about how quickly you can monetize the services that you're building, and that that pace really allows you to grow your business faster. So with that, I would give the stage back to Shabazz to talk about Sateliot and their role in providing IoT connectivity.
Thank you, Ajit, for walking us through. Really informative, and I really like it. All the possibilities that we can have through AWS. And about Sateliot, yes, we are the one of the success story you can call. Brief about us: we are the LEO satellite constellation based on the 5G narrowband IoT NTN standard. We allow the commercial unmodified cellular IoT devices supporting the NTN extension from the space. When I say unmodified, it's talking about the standard. We are fully standard from end to end. We are also a member of 3GPP, GSOA, GSMA, and GCF. We, from the space sector, we have the largest contribution to 3GPP release 17. We are also the first member from space in GCF. We are pretty active in pushing the overall ecosystem for the faster, massive adoption of IoT across the globe. If we talk about our value proposition, so we are talking about coverage everywhere. When we say coverage everywhere, we are saying that we have the ability to connect and communicate with the IoT devices across the globe, including the remote and hard to access regions where the terrestrial coverage is not able to serve. Here, I would like to mention that we are not competing the terrestrial cellular operators. We are working hands in hands with them and act as a coverage extension for their service. We'll talk about it, how it's being done. We are talking about standard devices. As I say, it's unmodified, fully standard 3GPP release 17 based devices, which allows the dual mode connectivity for both terrestrial and non-terrestrial connectivity. And that's what we are extended. Our solution is not proprietary. We are fully standard end to end, from the UE from till the MNO core. So we are following the standard. Then we talk about the seamless service. When you say seamless, from a customer perspective, it's seamless. It's the same SIM card, same connectivity, same SIM connection from a cellular, their existing cellular operator, which allows the dual mode connectivity on the devices. The same device will be able to connect to this terrestrial network on the cellular side, and whenever it's out of coverage, so we will serve the same device as the roaming partner to our MNOs and MVNOs ecosystem. And then at the last, we're talking about low cost. Is the cost-effective satellite IoT? We are LEO. Our total cost to operation is much more lesser as compared to the other solutions. But we are talking about the low cost. The total cost of operation is much lower for us. So that's what we are offering to the community, to the NTN community, and to the end customers as well. Lastly, if we say how we are doing it, what we are offering to the MNOs and through our core, we are fully standardized, I say, which is the seamless end user experience. The customer keeps, as I mentioned earlier, the customer keeps one point of contact from the billing, from the contract, from the support. It's the same MNO they will talk to. It's the standard roaming integration, as we are following the standard GSMA MOIT guidelines. So we are fully standard end to end. We implement the standard industry practices, standard way of integrating to the MNOs. So our network operability is pretty seamless, and is the same as an MNO or MVNO integrates another roaming partner in their network. So from the network side, there is no investment on the MNO or MVNO. You do not need to have additional network investment on implementing the narrowband IoT network for your customers, we will take care of it from the roaming side. So from an integration perspective, it's standard. From a network investment, there is no such investment for MNOs and MVNOs. And then we, as I mentioned earlier, we are talking about unmodified commercial dual mode modules. Thanks to the ecosystem, the work in the ecosystem is being done. You will see very soon different announcements from different chipset and module manufacturers who are working along with us in this ecosystem. The ecosystem is building up. This is the first time, this is the history that is being made. Companies are working, we are working also with the ecosystem. So now the need of the time is to push the early commercialization of the solutions. We're not alone in this journey. We need to work with the ecosystem. We are working with the chipset manufacturers, device manufacturers. We are working with the MNOs, with MVNOs. We are working with the central industry forums like GSMA, 3GPP, where we are also collaborating and contributing with the other satellite operators. And then we are also working with the hyperscalers like AWS, thanks to them, who are enabling us as a standard narrowband IoT 5G satellite connectivity provider to have this solution for our customer and for the customers of the MNOs and MVNOs. So that's the power of the overall ecosystem. That's what we need to work together to have the maximum and speedy adoption of the massive IoT across the globe. So thank you very much. Thank you, Alex. Thank you, Ajit. Over to Alex.
Thank you so much, Shabazz and Ajit. I believe we have one question in the chat. I think it's for Shabazz. So maybe you can go back to the use cases. They're asking if you can describe 3 use cases, one for broadband, critical missions, and IoT. And then there's a bit more on that question.
If you can go to the slide, and then while I can read the question and I can answer. It's okay. So from yeah, this is fine here. So from the 5G NTN network core capability perspective, if you could talk about the implementation of the core architecture in each of the domains, I would say there are some parameters which would needs to be done and incorporated in the implementation of the core side of the direct to device, and especially broadband when you need to have the higher throughputs. So maybe this question can be better answered from an OSS and BSS perspective by Ajit as well. What are the different elements, how the implementation of the core could be different? But from an IoT perspective, I can say that it is pretty much standard in the implementation. The basic core functions of the architecture are pretty similar in each of the domains, but of course there would be some elements which needs to be taken care of. Yes, Ajay.
Yes, absolutely, Shahbaz. So if you look at, I mean, this will follow the same principles of deploying a 5G core. So as I mentioned earlier, you would still have the network slicing and authentication functions built in your core, and you would have the user plane functions, which would do the charging and billing, which would do the handoff to the transit running at edge. Obviously, at narrowband, you will not be looking at a very scaled environment. Like the data transfers will be much lower as compared to say a terrestrial 5G network, and that would kind of mean that the amount of capacity that you need to run these functions will be much lower as compared to telco to terrestrial networks. However, it would still mean that you will have to run the same functions. You still need to kind of charge your customers that are passing directly from the edge. You still need to have that integration on OSS and BSS. You will still need the same functions to kind of provide a holistic 5G standard, because you are kind of handing off the traffic to terrestrial networks, as in your case you do with Telefonica. So you need to have essentially run a full stack of 5G, but at a lower scale, given that the data rates are going to be lower for IoT use case.
Thank you, Shahbaz, Ajit. I do have a couple more questions. This one for Shahbaz. Could you tell us a bit more on the standard roaming integration? How is it much easier from the MNO and MVNO perspective to be integrated in the 5G NTN ecosystem?
Yeah. Uh, so what we are doing is the leveraging the power of the standard. So when we say is the standard roaming integration, we are following the standard GSMA MOIT guidelines. Is the same standard integration using the standard interfaces S6A, S8 control plane, user plane. These are the standard roaming interfaces. So from an MNO perspective, we are talking about the standard roaming integration as they do with any other terrestrial cellular operator across the globe. So we are implementing the integration through industry practices like VIPX. So we are following the same methodology. It's the standard 4G PC core, if you see from a core perspective. And so from an integration, it's seamless. It's the similar way. That's why it's helping us when we are following the standard. So we sign the same roaming agreements as they are being signed across the globe. We are a full GSMA operator member. So and using the standard core implementation on AWS. So it is standard, I would say, from an MNO or MVNO perspective to see us and the implementation of 5G NTN in a very seamless way. It is nothing new to be done. That's the power of the standard.
Shahbaz, much clear now. There is another question from Eric coming. I think it's for Ajit. It says, what is the opportunity to co-locate an AWS managed outpost with a remote 5G NTN downlink to extend the AWS cloud environment?
Absolutely. So thanks, Eric, for the question. Indeed, it is completely possible to have an outpost at an edge location, and that was also one of the points I made during the presentation. We do have a reference architecture that talks about various possibilities of what is possible and when you should use which kind of service. Uh, Outposts is an extension of AWS services into your own environment through AWS hardware, but the limitation is that Outpost needs always on connectivity, right? This is obviously perfect for 5G deployments in terrestrial network, because you need to have a connectivity to 5G core anyway. But there may be certain situations, I speak with few customers who are already also building their own 5G core for NTN, and they have considerations where their ground segment locations cannot have always on connectivity with AWS region. So in those cases, you may be looking at something like Snow family devices, like a Snowball Edge or Snow Cone, to kind of do those things at disconnected environment, right? However, if you have the ability to have an always on connectivity, absolutely you can have outposts to run your distributed functions inside an outpost connected to an AWS region.
Okay, understood. I think there's some more questions coming. Is it one clarification about NTN? Okay, I think it's for Shabazz. What NTN modifications have been made to the 5G core and the Node B from a terrestrial network? I don't know if you can clarify that, Shabazz.
Yeah. Okay. So from the NTN modifications in the standard Node B in the core, there aren't much. We are extending the same protocol to the Node B, or you can call it eNode B. So it's the extension of the same protocol. That's why we call it a standard way of communication. Yeah, I can see the next question is for the 5G core or 4G PC core. From a core perspective, From the narrowband IoT, it's the standard 4G PC core, which you can extend to implement the narrowband IoT integration. I can quickly answer the last. I can see the how Sateliot is dealing with the handover with just few satellites. We can have a detailed session about it. We have a novel technology called store and forward. We have also a public white paper around it. We can shortly talk about this. Alex will give you the contact again, and we can surely talk about it, how it is being implemented, and as the constellation will grow, how we will have it more real time connectivity across the globe. That's what we say. We are currently supporting the delay tolerant application, and this question is the right question, how we are doing it. This is the power of store and forward technology, how we are implementing it. So yes.
Right, when the recording of the webinar is going to get posted, I will provide with the answer and about the documentation about the store and forward methodology that is novel to Sateliot. And if you have any other technical questions, leave them in the chat of the post, and we will go through it now, right after the webinar finishes. So I think it's time to call it off. Thank you, Shabazz and Ajit, for preparing it. And see you next time. I don't know if you want to say anything.
I think thank you very much, Alex and Ajit. Thank you to NTN community for arranging this webinar. I think that the need of the time is to that the whole ecosystem, as I mentioned, needs to work together to make it happen, to make it commercialized, so that the end customer should start taking benefit as early as possible. Thanks a lot.
Okay, thank
Thank you,
you.
everyone.
Bye-bye.
Bye.
Thank you. Bye.